Question 1. What is the primary benefit of using Azure App Services deployment slots for application updates? Option A. Reducing the cost of app service plans. Option B. Enabling zero downtime deployments and easy rollback. Option C. Providing a separate app service plan for each application version. Option D. Automatically scaling the application based on traffic. The correct answer is, quote, enabling zero downtime deployments and easy rollback. Here's the explanation. Deployment slots are designed to facilitate seamless, zero downtime application updates by allowing new versions to be tested in isolation and then swapped with production. They also offer an inherent rollback capability. Question 2. A developer has configured an Azure App Service with a production slot and a staging slot. They have defined an app setting named database connection string and marked it as a slot setting in the Azure portal. Another app setting named feature toggle is defined but not marked as a slot setting. What happens to these settings during a slot swap from staging to production? Option A. Both database connection string and feature toggle swap with the application content. Option B. Both database connection string and feature toggle remain with their original slots. Option C. Database connection string remains with its original slot, while feature toggle swaps with the application content. Option D. Feature toggle remains with its original slot, while database connection string swaps with the application content. The correct answer is database connection string remains with its original slot, while feature toggle swaps with the application content. Here's the explanation. Settings marked as slot specific or sticky, like database connection string in this case, remain with their respective slots during a swap. Non-sticky settings, like feature toggle swap along with the application content to ensure the correct configuration moves with the correct code version. Question 3. A company wants to implement Azure App Services deployment slots for their web application to perform A/B testing and ensure zero downtime deployments. Which of the following app service plan tiers supports deployment slots, and what critical step helps prevent cold starts during a swap operation? Option A. Basic tier. Automatic scaling. Option B. Standard tier. Warm-up actions. Option C. Free tier. Traffic routing. Option D. Shared tier. Rollback capability. The correct answer is Standard tier. Warm-up actions. Here's the explanation. Deployment slots are only available in Standard, Premium, or Isolated App Service Plan tiers. Warm-up actions are a critical step during a swap that ensures the application in the target slot is fully initialized and responsive before traffic is redirected, preventing cold starts and ensuring a smooth transition for users. Question 4. A developer needs to quickly deploy a Docker container to Azure for testing a new stateless API. They want to avoid managing any virtual machines or Kubernetes clusters. Which Azure service is the most appropriate choice for this scenario? Option A. Azure Kubernetes Service, AKS. Option B. Azure App Service. Option C. Azure Container Instances, ACI. Option D. Azure Virtual Machines, VMs. The correct answer is Azure Container Instances, ACI. Here's the explanation. ACI is explicitly designed as a serverless solution for running Docker containers directly in Azure without managing underlying VMs or orchestrators, making it the fastest and simplest way for quick deployments like testing stateless APIs. Question 5. An Azure solution architect needs to deploy a containerized application that requires a sidecar container for logging and monitoring. Both containers must share the same network and storage volumes and have a shared lifecycle. Which ACI feature should the architect utilize? Option A, VNet integration. Option B, container groups. Option C, persistent storage, Azure files. Option D, managed identity. The correct answer is container groups. Here's the explanation. Container groups allow the deployment of multiple containers that share the same lifecycle, network, and storage volumes, which is ideal for sidecar patterns where helper containers run alongside the main application container. Question 6. Which statement accurately describes a key characteristic or limitation of Azure Container Instances, ACI? Option A, ACI provides built-in advanced load balancing, service discovery, and auto-scaling for complex microservices architectures. Option B, ACI supports GPU-enabled SKUs for both Linux and Windows containers for compute-intensive workloads. Option C, ACI is a serverless solution where users are billed per second for the allocated CPU and memory resources. Option D, ACI requires users to manage the underlying virtual machine operating system and apply security patches. The correct answer is ACI is a serverless solution where users are billed per second for the allocated CPU and memory resources. Here's the explanation. ACI is a serverless solution with per-second billing for allocated resources. Option A describes AKS or container apps, not ACI. Option B is incorrect because GPU support in ACI is for Linux containers only. Option D is incorrect as ACI abstracts away all VM and OS management. Question 7. Which statement accurately describes the responsibility split between Azure and the user in an Azure Kubernetes Service, AKS, deployment? Option A, Azure manages both the Kubernetes control plane and the worker nodes. Option B, the user manages both the Kubernetes control plane and the worker nodes. Option C, Azure manages the Kubernetes control plane while the user manages the worker nodes. Option D, the user manages the Kubernetes control plane, while Azure manages the worker nodes. The correct answer is Azure manages the Kubernetes control plane, while the user manages the worker nodes. Here's the explanation. AKS is a managed service where Azure handles the entire Kubernetes control plane. Users are responsible for provisioning, configuring, and managing the worker nodes, VMs, where their applications run. Question 8. A solution architect needs to deploy an AKS cluster where pods require direct IP addresses from the Azure Virtual Network, VNet, for seamless integration with existing VNet resources and to support Kubernetes network policies. Which networking model should be chosen for the AKS cluster? Option A, KubeNet. Option B, Azure CNI. Option C, Calico. Option D, Flannel. The correct answer is Azure CNI. Here's the explanation. Azure CNI assigns pods IP addresses directly from the VNet, enabling advanced networking features like network policies and direct VNet integration, which is suitable for this scenario. KubeNet uses an overlay network and conserves IP addresses, but doesn't offer direct VNet IP assignment to pods. Question 9. A developer wants to automatically increase the number of running application pods in an AKS cluster when CPU utilization exceeds a certain threshold. Which Kubernetes component is responsible for this type of scaling? Option A, Cluster Autoscaler. Option B, Node Pool Autoscaler. Option C, Horizontal Pod Autoscaler, HPA. Option D, Vertical Pod Autoscaler, VPA. The correct answer is Horizontal Pod Autoscaler, HPA. Here's the explanation. The Horizontal Pod Autoscaler, HPA, automatically scales the number of pods in a deployment or replica set based on observed CPU utilization or other select metrics. The cluster autoscaler scales the number of worker nodes. Thanks for watching. Please subscribe to my channel.